In the next exercise, the setup is largely the same. We're still dealing with these full-blown truth tables. However, in exercise number 2, there are a couple of key twists. The twists are as follows. First of all, in exercise 2, we're dealing with two statements instead of just a single statement. So this makes it a little bit more complex, a little longer that is, because we've got two statements to solve for. Statement number 1, the one on the left, and then the second one, the one on the right. Further, not only are we dealing with two statements, and actually we'll be comparing the two statements, but we also have some new vocabulary to go through. Logically equivalent, contradictory, consistent, and inconsistent. So there are a couple of key concepts to get down. So let me get to it by jumping into the first problem, which I've gone ahead and copied down here exactly as it's given to me in the text. Statement 1, we've got not D or B. And statement number 2, we've got not D and not B. So to begin the problem, we need to construct our truth table. We begin, just as we did in the previous section, by counting the number of unique variables. In this case, there are two. We've got D's and we've got B's. For the purposes of counting unique variables, we'll treat these as though they're one big statement. We want to know total between the two, how many unique variables. D's and B's, so 2. Plug that into our formula. Hopefully you've now got this committed to memory. 2 to the power of 2 is 2. 2 to the power of 2 rather is of course 4. And so there are 4 lines in our truth table. Take that number 4, divide by 2. And so starting on the far left hand side with our first statement, 4 divided by 2 is 2. We start with 2 consecutive T's, followed by 2 consecutive F's, and that fills up all 4 lines of our truth table. Once you've defined a variable, define it in the exact same way. Notice now that the second appearance of D is in the second statement. Makes no difference. Even though the second appearance of D is in the second statement, define it nonetheless in the exact same way by repeating that pattern directly underneath it. T, T, F, F. Now, moving left to right, we've got one more variable to define, and that's the B. And defining the previous variable D, we started with 2 consecutive T's, so we'll take that number 2 and divide it by 2. 2 divided by 2, of course, is 1. So in defining B this time, we'll start with but a single T, followed by a single F, and repeat that pattern until we fill up all 4 lines. Once you've defined a variable, define it the exact same way. Even though the second appearance is in the second statement, makes no difference. T, F, T, F, all the way down. So now that gives us our truth table. From here, we solve those truth tables for the first statement and then the second statement. No real particular order, but solve them as though they were, for now, separate problems. So I'll start with the first one. Main operator is the wedge, so I need to take care of the tilde first. T becomes false, T becomes false, F becomes T, F becomes T, and now I can take care of the main operator, the wedge, comparing this column to this column. F or T, true, F or F, special case false, T or T, true, T or F, true. Circle the column underneath the main logical operator. We're finished with that statement. Now on to statement 2. Main operator here is the tilde. So let's ignore that for now, focusing in just on the inside of the parentheses. Main operator on the inside is, of course, the dot, so we need to take care of the tilde on the inside first. T becomes F, F becomes T, T becomes F, F becomes T. Now to the dot. T and F, false, T and T, true, F and whatever, false, false. Now the main operator. F becomes T, T becomes F, F becomes T, F becomes T. Circle the column underneath that main operator, and to finish this problem off, we now need to apply the vocabulary. The vocabulary, as seen here in the directions, are as follows. Logically equivalent, contradictory, consistent, and inconsistent. To determine which of the 4 possibilities our two statements are, we're comparing these circled columns, line by line. So 4 lines in our truth table, I'll number this just for convenience, and we'll compare the two statements line by line. In the first line, they're both true, and the second line, they're both false. In the third line, they're both true, and in the fourth line, they're both true as well. So here now are the definitions of our terms. If the two statements were logically equivalent, then they would have the same exact truth value on each respective line. Same value on each line. That's the definition of logically equivalent, LE for short. So where one's true, the other's true. Where one's false, the other's false. And In fact, here on this first problem, we can now stop. These two statements are logically equivalent. They've got the same truth value in each respective line. Where one's true, the other's true. Where one's false, the other's false. Where one's true, the other's true. And line 4, again, they both turn out to be true. So they're said to be, in other words, logically equivalent. So we write that down, logically equivalent, and that finishes off number 1. If that didn't hold, if they weren't the same truth value in each line, they might be the opposite truth value. And that's the very definition of our second term, contradictory. Contradictory, the opposite truth value on each respective line. Where one's true, the other's false, and vice versa. Where one's false, the other's true. If neither of those two terms apply, then we need to go on to our second group of terms. If they're not logically equivalent or contradictory, then our two statements will either be consistent or inconsistent. If the two statements are consistent, then there will be at least one line where they both turn out to be true. If there isn't any such line, then they're said to be inconsistent. No such line where they both turn out to be true. So that's our new vocab for this particular section. Logically equivalent, same truth value in each respective line, all the way down, no matter how many lines there should be in our truth table. Contradictory, opposite truth value. Where one's true, the other's false. If neither of those two terms apply, this is a stronger test, but certainly you'll see in this exercise cases where neither of these two terms apply. If neither of these two terms apply, then you go on to this test. If they're not either of these two, then it'll be either consistent or inconsistent. Again, consistent. If they're consistent, there will be at least one line, at least one. There could be more, but one will do. At least one line where they both turn out to be true. If there's no such line, then it's inconsistent.